Hello, my name is Scott Cheatham and I'm with the Richmond Hospital Education Program. And today we're going to be looking at a second lesson on an introduction to factoring. Now factoring is a topic that comes up starting in Algebra 1 and beyond into Geometry Algebra 2 and the rest of your high school math career. And so this video series on factoring will be helpful for those of you that are first learning it, or if you're in Geometry or Algebra 2 and just need a refresher. This is going to go through some of the basics on factoring, primarily now looking at quadratic equations and factoring. There are going to be times today where you're going to need a scratch paper just to kind of be able to work out a couple problems on your own. And so there will be also times where I might ask you to pause the presentation to kind of work on some and then come back and start it, and we'll talk about those answers. You won't really need a calculator. You're welcome to have a calculator with you to kind of work through some of the problems just from a purely four-function calculator perspective, but you won't really need a calculator to solve any of these problems. Now today is primarily going to be looking at factoring and rewriting polynomials from an algebraic standpoint. I will admit that this is focuses not as much on word problems or on how these can be used in real world situations, but more on just kind of skills and strategies for rewriting these polynomials. Now, a term we want to review today before we get into the lesson is GCF. And hopefully you remember what that means. That means the greatest common factor. We want to know what the greatest values are that we can factor out, both from the coefficients but also from the variables. And so here, what is the GCF of 25a squared and 15a? Well, that's 5a. So the number that we can factor out of both 25 and 15, the largest number that we could divide out would be 5. For variables, you've got a squared and a, and really it's going to be the lowest exponent of the variable that you have in all of your terms. And so you have 5a as your GCF. But let's go one step further. Rather than writing, okay, well, what's the GCF? Sometimes it's worded a little bit differently. Sometimes it might be written as factor 25a squared and 15a. And this is different than asking just what is the GCF. When we do this, we're actually going to find the GCF and rewrite it as if we've divided it out from each term. So when we have 25a squared plus 15a, that's going to equal our GCF of 5a on the outside, but then we're going to remain and leave the terms, the remainder of what we've divided out. So we've got 25a squared was that first term. If we divide out the 5a, what do we have left? And that's going to be 5a. Then for the second term, we've got 15a, and we divided out 5a. And you divide out the numbers, the coefficients we divide. For variables, when you're dividing, you're subtracting exponents or canceling, and we get just the number 3. Now you can check your answer by distributing, and so you've got 5a times 5a is 25a squared, 5a times 3 is 15a. So when we see this written as factor a binomial here, we want to the first thing we want to look at is there a GCF that we can factor out? So when we look to find that GCF, we're asking ourselves, what number can we divide out from both 18 and 12, and what variables can we take out from if we have x squared and x to the third? In this case, it's going to be 6x squared. Then we're going to divide each term by that GCF. And when we do that, we're still going to leave the terms there. We're not just saying that 6x squared is our answer. We're going to leave that 6x squared on the outside. 18x squared over 6x squared. When we divide those, the x squareds cancel. 18 divided by 6 is just 3. And then we've got 12x to the third over 6x squared. When we divide those, we're left with 2x. And then we can check our answer by just distributing. And we multiply those together, we do get 18x squared minus 12x to the third. All right, so what I want you to do, I want you to look at this one and see if you can determine, okay, how would you factor it? So if you need to go ahead and pause it, I just want you to decide, okay, what would the GCF be? And then we'll talk about how we'll divide that out. So our GCF here is 28AB. And so for the 28 part, hopefully that wasn't too hard. 28 goes into both 28 and 56. In terms of the coefficients and the GCF, the numerical part there, it's not going to be larger than the smallest number. So it couldn't ever be like larger than 28. It's a good strategy to start with kind of whatever that smallest number is and see if that goes into everything, because that's going to be your GCF. Now from the variables, it has the variable and whatever exponent we're going to use have to appear in all the terms. So when I look at that first one, a squared is in the first term and a is in the second one. I only can use a to the first. For the b, I've got b in both. It's both b to the first power, so I can use b. And for c, I don't have any c's in my first term there, so I cannot pull out a c. That c squared has to remain in the second term. Now when I divide each term by that GCF, I'm going to pull that out. I'm always going to still write that there. But then what's remained, I'm going to determine 28 a squared times b over 28ab. Pretty much everything cancels out there except for the a. For the second term, I've got 56ab c squared. Well, the 56 divided by 28 is 2. The a cancels, the b cancels, and the c squared remains. And then you can check your answer by distributing. And we would have our original problem. All right, now I'm going to give you 2 to do on your own, and I've given you the answers in multiple choice. So I'm going to kind of let you determine these, and I'm going to pause it, and then let you come back when you're ready to see the answer. So for this one, the GCF was 4x, and when we divide that out, we get 5. Now for this one here, I want you to see if you can decide what would the GCF be. And the GCF in this case is 7. There's a number of variables in here, but there isn't a variable that appears in each term that we can factor out. So we're just going to divide each term by that GCF of 7. And when you do that, you get 7 on the outside, 28a squared over 7. The variable's not going to be affected here, and we just have 28 over 7. 4a squared. 21b divided by 7, again, the variable is not affected. We have 3b. And 35b squared, c squared over 7. 5b squared, c squared. And we can check our answer by distributing, multiplying 7 times each one of those terms, and we do end up getting our original equation. Or excuse me, original expression. So go ahead and try factoring this one. You got to determine what the GCF is and then see what it would look like when you divided that out. And our answer here is 8y squared. Then you have 2x, 3z, and 5x, or minus 3z and 5x. You want to be careful here when you get the variables and the exponents that you are paying attention. That's something that you can easily include one in the GCF that shouldn't be there. It might be in 2 of the 3 terms. Again, the variables have to be in all three terms to factor them out. Now, why we started with GCFs is that one of the first most important things we're going to do as we look at the different types of factoring is we want to make sure if we do have a GCF that we factor that out first and divide that out first. So if you'll recall from the previous lesson on factoring the difference of two squares, if you have two perfect squares and it's a difference problem where there's a minus sign, you can, there's a little kind of shortcut where you just take the two square roots, put them in binomials, one's got a plus, one's got a minus. It's the same idea if you, rather than thinking of it as x squared minus 4, if you thought about it as x squared plus 0x minus 4. When we have trinomials with that leading coefficient of 1, it's what two numbers multiply to get negative 4 that add to get the middle number of 0. In this case, be 2 and negative 2. So I want you to use that idea of difference of two squares to factor these completely, but be mindful of your GCFs. So be careful with those if you have any that are going to have GCFs here. So go ahead and pause this and use that difference of two squares to factor, but first step, make sure that you factor out any GCFs. And here are the answers. You've got x plus 10, x minus 10 for that first one, but notice that you do have to factor out the 2. So that 2, when you factor that out, you end up with x squared minus 100, which is two perfect squares that we can use. Same idea goes with the second one. You've got that x that you can factor out, and then it becomes x squared minus 36. The remainder of them, one of them, number 3, was not factorable because it wasn't a difference problem. It does have to be a minus sign there. 4, when you have higher exponents there, that goes into some exponent properties. The x to the 6th, if you want to know what the square root of that is, it's x to the 3rd. Now the last one there, you don't want to make sure you factor completely. When you factored that one, you got x squared minus 1 as part of your answer, and then you have x plus 1 and x minus 1 that you could continue factoring a second time. So for this one, factoring trinomial with a leading coefficient of 1. So for this one here, we've got x squared plus 7x plus 1, or plus 10. For all of these where the leading coefficient of 1, this is a little bit of a review, this phrase, what two numbers multiply to get the third number that add to get the second. So see if you can decide, okay, what two numbers multiply to get the third that add to get the second. Those are going to be the numbers that are going to go into your binomials. And so, as we've talked about before, the signs are important to look at. That second sign, if it's positive, that means the two numbers are going to have the same sign. The first sign tells you what that's going to be. If the second sign is negative, that means that they're going to have opposite signs, and you've got to look at that middle term to see, okay, which number is going to have either the positive or negative based on that. Now, all of those were things that we've done before. Today we're going to focus on factoring when the leading coefficient is greater than 1 or not 1. But I do want to show you this special case. This is a formula. It's called a perfect square trinomial. It is not as popular, and you don't see it as often as the difference of squares. But basically, if you follow this, you're saying if your outside terms, if they're perfect squares, and the middle term is those multiplied together and doubled, or 2 times those together, it's called a perfect square trinomial, in which case we can write it like this. So let me show you what these would look like. So because x squared and 36 are perfect squares, the square roots of those are x and 6. 2 times x times 6 is our middle term of 12. We can write this as x plus 6, quantity squared. If you wrote it as x plus 6 times x plus 6, that's the same thing. I think this is somewhat helpful to see it, but if you just remember if you think of it the other way, what two numbers multiply to get 36 and add to get 12, and you see it 6 and 6, you're going to be able to factor this without having to memorize a formula like this. But this is something that sometimes comes up, or you might see this terminology, so I wanted to show it to you. Same idea goes for 16. Square root of 16 is 4, square root of x squared is x, but it's a minus 8x as the middle term, and then that just makes that negative 4 negative in our binomial there. Again, this is one that I don't think it's as important for you to memorize. Your teacher might, at your homeschool, might feel differently, but I did want to show it to you as a way of getting you familiar with that phrase, because you might see that. All right, now, as we're moving forward with these factoring problems for today, an important rule that we're going to always ask is the first thing you look at is there a greatest common factor? Because you can make your life really challenging if there is a greatest common factor and you don't pull it out first. You can theoretically do it at the end, but you've just dealt with much larger numbers than you needed to for that. So for both of these, I want you to see what would it look like if you factored out the GCF. Taking note of my second statement there, you always want to factor out the ax squared so it's positive. So for number 2 there, you got a negative 2x squared. I want you to factor a negative out to make that positive. So go ahead and factor out the GCFs. And then go ahead and factor these two. So our GCF for number 1 is 5. We can't take out any variables because that 30 is just the constant 30. And then we're left with x squared plus 5x plus 6. And at that point, you almost can ignore the 5. You do need to keep writing on every line there. But then it's just a factoring problem of factoring that trinomial. What two numbers multiply to get 6 and add to get 5? That's 3 and 2. And you do need to make sure you write the 5 in your final answer. It's a very common thing where people will factor out the GCF and then it just kind of vanishes and people forget to write it on every step. Make sure you write that on every step. Now for number 2 here, we have a negative 2 as our GCF that I wanted to take out. And the reason that taking out that negative 2 is it makes it so the x squared is positive. And that allows us to look at this, okay, what two numbers multiply to get negative 18? That add to get negative 7. Answers are negative 9 and 2. Again, making sure we bring that negative 2 down and write that with it. Now, for the remainder of this lesson, we're going to look at factoring trinomials when the a, or that leading coefficient, is greater than 1. We don't always get nice trinomials where it's just 1x squared. And while that phrase of what two numbers multiply to get the third that add to get the second is nice, that really only works with the 1x squared trinomials. There are 2 ways that we're going to go over for doing this, and they're ones that are a little bit more focused on kind of the logic and mathematics behind it. I will be the first to admit I know that you can go on the internet and find all sorts of tricks to do this where it's not necessarily allowing you to understand where the numbers you're getting are coming from. And so if your teacher uses some other methods, that's fine. But I would suggest kind of listening to these first before going off and looking for some tricks. So our trinomial here is 2x squared plus 11x plus 12. Now, what we've talked about before about the signs, that's still going to hold true for that second sign, meaning, okay, if it's positive, then we're going to have the same sign, and whatever the sign is going to be whatever the first sign is. So in this case, I got plus 12. I know that that means that the binomials are going to have the same sign. We've got plus 11x, meaning they're both going to be positive. So you can see I kind of put in some blank ones here. Now, if we think back to that term FOIL, the F stands for first, meaning when you are expanding these binomials, the first terms in those binomials you multiply, that's going to be your first number. And then the last one, the L, is the last terms in the binomials, and that's what's going to give you your third term. Now the O and the I, those are going to typically be your like terms that you're combining, so we're not going to focus on those to start. But what I do know is the 2x squared, if I just look at that 2, the factors of that have to be the first numbers in the binomial. And for the 12, the factors of that are going to be the last numbers in the binomials. So if I list out these factors, I can do what I'm calling trial and error. Some people call it guess and check, but really kind of taking a logical way of looking at it and seeing, okay, well, what numbers do I know either have to be in there, or can I kind of play around with this, see what I can do to, when I do plug in these numbers, will give me my middle term of 11x after I expand it. So the first numbers are going to have to be 2x and 1x. Those are the only factors of the number 2. And so to get 2x squared, I have to have those first two numbers be 2x and 1x. Now for the second blanks, there are going to be some factors of 12. And whatever factors of 12 they're going to be are going to be ones where when I FOIL it out with the 2x and the 1x, it's going to combine to give me a like term of 11x in the middle. So I've really got 3 pairs to play around with here. And actually the way it ends up working is, because those pairs I could flip, there's really 6 different options here. So you could try all 6 and see which one gives you 11x. But I put this question here, did we have a GCF? Because if you remember, that was the first thing we wanted to look at. And for 2x squared and 11x and 12, there is no GCF. Well, what that means, I put in red the 6, 2, 4, and 12. If I was to put 6, 2, 4, or 12, any of those red numbers, in the first binomial, I would have actually something I could factor out, because those are all even numbers. So if I put in that 2x plus 6, I should actually be able to factor out the 2 and have a GCF of 2, which I know based on my original expression there, I don't have. So what that eliminates is none of those numbers can be in with the 2x. I really am down to this 3 and this 1 as the ones that can be in there. And from there, it's just kind of trial and error. Okay, so if I plug in 3, I also could try the 1 with the 2x and the 12 and really just kind of multiplying that out and seeing which one works. And so the 3 being and 4 are the ones that work there. Again, if I FOIL that out, I get 2x times x, which is my 2x squared, 2x times 4, which is 8x, 3 times x, which is 3x. Those two combined to give us our 11x, and 3 times 4 is 12. So for this one here, what you notice is that I have 2 pairs of numbers for the 4, and I also have 4 pairs of numbers for the minus 35. Because it's minus 35, I'm going to have some combination of one of them's going to be positive and one's going to be negative. And so for this one, when I'm plugging it in, I've got to try plugging in the 4 and the 1, and plugging in the 2 and the 2. Luckily, there's not too many pairs that I can see, and I would really kind of just play around with them and see which one works to, when I FOIL it out, give us my middle terms of negative 23x. My answer here, when I did that, was 4x plus 5 and x minus 7. Now, this method is going to be helpful, especially when that first term is prime. That's something where if it's 2x squared, 3x squared, 5x squared, because you know what those first terms are, and it's a little bit easier to plug in the options for the last terms in the binomials. When it's a number like 4x squared, it's still doable, but it might take a little bit of time. I'm going to show you a second method in just a minute, but I want you to just practice around with some of these trial and error ones, making sure that you look for a GCF before you factor it out. So go ahead and pause this, and then I'll kind of go through what the answers would be, doing these using that trial and error method, plugging in the signs that you have, making sure you factor out your GCF. So that first one there, I know it's 3x squared, so the first terms are going to be 3x and x. For 6, I've got factors of 6 and 1 and 3 and 2, and so it's really just kind of plugging those in and seeing which one works. Again, I didn't have a GCF, so I would not be able to put a factor of 6 or a factor of 3 in that first binomial with the 3x, because then that would give me a GCF to take out. So my answer here is 3x plus 1 and x plus 6. Now I had very similar numbers to the first problem with this one. Still the 3x squared, so I'm going to have 3x and x. But for minus 6, I'm going to have opposite signs. I need to combine them to get 7x. So I got to play around with it, trial and error, see which ones worked. It's 3x minus 2 and x plus 3. Now for number 3 here, I did have a GCF of 2. So I want to make sure I take that out before I try and factor any of those. Get 3x squared plus 11x plus 6. Again, I've got 3x and x. Factors of 6 are just 3 and 2. I've already taken out my GCF, so I shouldn't have any GCFs in my binomials. There's my answer. And the last one here, 2x minus 5 and 2x plus 3. 15 doesn't have too many factors, just 5 and 3 and 15 and 1, and you got to have opposite signs on those. For 4x, you could have had 4x and 1 and 2x and 2x. It does take a little bit of trial and error, but the more you get comfortable with that, the easier it will be. I will say that the trial and error method for the ones, again, those ones where that first term has got a prime number as the coefficient, I think that as you get comfortable with it is the easiest one. The other processes that I'll show you take a little bit more time, but again, they will always work for you no matter what those first terms are. So before we look at this second method, I just wanted to ask you this. So 5x times $sign plus $4. If I asked you what the GCF was and to factor it out, what would that be? And that money sign I would take out, and I would have 5x plus 4. And I show you that it's going to come up in what we're looking at next. But the GCF, it could have been that money sign, it could have been a number, it could be anything. But if you've got that in both terms, we can factor it out. And that's going to be important as we kind of look forward. So what I want for you to do before we go over this next process is to copy these down, copy these steps in your notes so you can refer back to them. There's a couple steps here. It'll make more sense as we go into them. But I want you to copy these 6 steps down. And what you'll know here is this is a way of solving it when the leading coefficient is not 1. The trial and error method worked fine when that first term was prime, but what if it was 12x squared or 24x squared? Something where you've got multiple factors that you got to plug in and play around with. There are other ways out there to factor it, and this is going to be one. It's going to be by what's called the grouping method, and it's going to be able to get you an answer every time, no matter what. So if you've already copied down those steps, we can keep going. But I'm going to show you this is a way of factoring any trinomial, no matter what the terms are. So your first step is, if possible, multiply out the GCF or divide out the GCF. In this case, there is none. So we can move on to step 2. Now, step 2 here says multiply together A and C. So multiply together those two, the 6 and the -3 in this case. And you want to find two numbers that get AC that add to get B. So this is similar to that other problem or other process when it was just 1x squared, with two numbers multiplied to get the third that add to get the second. But we do need to multiply AC together. So what two numbers multiply to get -18 that add to get 7? And in this case, that's +9 and -2. Again, it was the add to get +7, so the the larger of the numbers, 9 and 2, 9 is going to be positive. And so getting those two numbers, we can't just plug in and say x plus 9, x minus 2 like we did before. We have to do some extra steps. So step 3 is using the two factors that you found, rewrite bx as a sum of those factors. So what that means is rather than writing 7x, we're going to take the 9 and negative 2 and rewrite 7x as 9x and minus 2x. That doesn't change the expression at all. We've just rewritten 7x as 9x minus 2x. Step 4 is group the terms into binomials. So really all I'm doing is just putting parentheses around the first two. You'll notice I put a plus and then parentheses around minus 2x and minus 3. You want to kind of be careful how you put those parentheses. You don't want to change it into multiplying the two binomials. All I'm doing is grouping those two together. Step 5, factor out the GCF of each pair. What remains must, and if you did it correctly, should be the same for both groups. So for 6x squared plus 9x, I can factor out 3x. For minus 2x and minus 3, there isn't really anything I can factor out other than a negative 1. And so when I do that, you'll notice that I had both 2x plus 3 and 2x plus 3 left over. And then we're going to factor out the common binomial here. And what you'll notice there is that it ended up being 2x plus 3, kind of goes back to that dollar sign. If I had 3x dollar sign minus 1 dollar sign, I'd factor out the dollar sign. Well, what I have here is 2x plus 3 in kind of the place of that dollar sign. And so I ended up with 2x plus 3 times 3x minus 1. So what I would like for you to do for these last two is to follow that process, follow those steps, and to go ahead and see if you can factor these. Again, these are ones where trial and error probably wouldn't be the best way to do it, because 8x squared is going to have multiple different factors that you would have to trial and error and do it. So I want you to try that grouping method and go through these two. I'll go ahead and pause the presentation here. So there was no GCF. When you multiply the first two together, A and C together, you get negative 48 and negative 13. So what two numbers multiply to get negative 48 that add to get negative 13? It's negative 16 and 3. Then I group those together after I rewrote negative 13x as negative 16x and 3x. Factor my GCFs of each of those separately, 8x and 3x. My x minus 2's are the same. And then I factor out that common binomial, get x minus 2 and 8x plus 3. For this one, don't see a GCF, multiply together A and C, and this is why this method is going to be helpful, because sometimes you get very large numbers. 24 times negative 15 is negative 360. So you might need to use a calculator here to determine, okay, what two numbers multiply to get negative 360 that add to get negative 2? It was negative 20 and positive 18. We then group those together. You get 4x times 6x minus 5 and 3 times 6x minus 5. Factor out that 6x minus 5, and now it's factored. This process, I'll say, it will work no matter what process or what factoring you have. I like to show you a couple different processes because I think it makes sense for you to see it a couple different ways. But this way will always work for a trinomial. And if you can't determine what two numbers multiply to get A, C that add to get B, then it's going to be one where it's not factorable. I hope this lesson has been helpful for you. If you are still with the Richmond Hospital Education Program, we have a subscription to IXL, and many schools do as well. So here's a module that you can do there to get some more practice with factoring when the leading coefficient is not 1. Again, thank you for listening to this. I hope it's been helpful, and I wish you well with the rest of your school year. Thank you.